in this section, we're going to start taking a look at more with logarithms, and specifically, we're going to start with some properties of logarithms in this section. And realistically, there's only going to be three things that we do in this section. We're going to be able to rewrite logarithms in an expanded form by using three rules. We're going to condense logarithms by using those same three rules. And then we're going to use something called a change of base formula to be able to approximate values of logarithms. Okay, so that should be pretty easy because that's just some calculator stuff. Three rules of logarithms that we're going to be using throughout this entire section. If the interior of a logarithm has two factors or more, what you can do is you could separate that into the sum of those two. Okay, we're going to see lots of examples of this. With a quotient, if you have two terms inside that are being divided by one another, then you can turn that into a subtraction of two logarithms. And then if you have a coefficient, what you could do is you could just turn that into an exponent. So this works for any logarithmic base, including the natural logarithmic function. Okay, and for those of you that are going on to calculus or even higher, you're going to be seeing this very frequently. Okay, so these rules do come up quite frequently in like calculus 2, calculus 1, differential equations course. So this is a really good exercise. These are a really good series of exercises for us to be able to see how to manipulate logarithmic expressions. So in these examples, we're going to use properties of logs to expand the logarithm as much as possible, and then to be able to evaluate expressions without a calculator and simplify. All right, so there were a couple really easy ones to start. Log base 12 of 15x. Notice it's being multiplied, so that means we're going to turn it into two logs and then sum. So this we can write as log base 12 of 15 plus log base 12 of x. And that's it. That's literally all we have to do to implement that rule. Almost the exact same problem, except this time we have a 144. So we're going to have log base 12 of 144. And again, being multiplied, so we're going to add, plus log base 12 of x. Now, how this problem is different is that this statement is evaluable, or we can simplify it. Remember what we did. We set y equal or x equal to log base 12 of 144. Remembering the phrase that a logarithm is an exponent. So x is the exponent, 12 is the base. So 12 to the x is 144. And we probably remember that 144 is the same thing as 12 squared. And if we didn't know that, we could just go in our calculators and fumble around with it until we figured it out. And so in this case, x would be equal to 2. And so we can now rewrite this expression as 2 plus log 12 of x. So we always want to try to simplify as much as possible. In a similar fashion, we have log base 4 of x cubed over 256. Now we're dividing. Whenever we divide, we subtract. And so this could be written as log base 4 of x cubed minus log base 4 of 256, all right? And so this is where we want to see if we can simplify these at all right? One thing that we could do to simplify this as well is to take this exponent of 3 and move it in front if we wanted to. So another way to write this would be 3 log base 4 of x. This statement we should try to evaluate. Okay, so down here, I'm going to set log 4 of 256 equal to x. Remembering the phrase, logarithm is an exponent, 4 is the base. So we get 256 equals base to the x. And this is where we want to go in our calculator and maybe look at the powers of 4 to see if 256 is one of them. So we know 4 squared is 16, 4 cubed is 64, but 4 to the 4th, I believe, is 256. All right, and that's helpful because now what we can do is we can rewrite this as 4 to the 4th equals 4 to the x, and then there's the 1-to-1 correspondence that 4 is x, and so this just becomes 4, right? So this is just one way that we could write this expression, okay? And by the way, this rule where we took this and moved it in front is actually going backwards. So we took this rule right here, and we just put the r down here, okay? So basically the r in this case was the 3. We would have this again, subtraction, but a natural log. So now this speech becomes the natural log of y to the fifth. Since we're dividing, it's a minus, and so that'll be minus natural log of e to the 17th. Right? We can use that exponent rule, and this 5 and the 17 can move in front. So we would get 5 natural logs of y minus 7 natural logs of e. And you probably remember from previous lessons that ln's and e's are inverses of one another. The ln of e is 1, and so we can write this as 5 natural log of y minus 17. One last example before we finish this video, and this one's actually probably the easiest one because we don't have to evaluate anything. Again, we have multiplication. So this is going to be a sum. And so this is going to end up being log 244 of x cubed plus log 244 of y to the 15th. And just like we've done in the previous examples, let's get these exponents and move them down. And so that would be 3 log of 244 x plus 15 log of 244 y. All right, so that's it. That's just our those three basic rules of logarithms to be able to operate on these logarithms, to be able to manipulate them, make them a little bit more simplistic, and then also to be able to evaluate when possible. All right. So in our next video, we're going to do the exact same thing. We're going to take a look at a little bit more difficult problems. And then also in subsequent videos, we're going to go the other way where we try to write them in the condensed form.